double integrals in polar coordinates. This theorem here says if r theta is continuous on a general polar region D as described above, then the integral of fr theta r dr d theta over the region D is equal to this integral we see here on the right. Now this looks a little complex. We can decipher this. Now this is just my function. This r we'll describe later. Don't worry about it now. When we get to the Jacobian, that's where that r is going to become apparent for us. And then we have dr d theta. Now one thing to notice here is this dr is attached to these bounds here. And you notice, I like what they did here. They said r equals and r equals. And they're both are equal to some function of theta, which makes sense. And then finally, the last integral I'm going to do is my theta from alpha to beta. So this problem below is where we're going to use this idea here. So it says in the following exercises, the graph of the polar rectangular region D is given. Express D in polar coordinates. So the first step in setting something up in terms of an integral like this to try to find a volume, and that's in general why that's used, at least in this section, we have to understand turning certain regions into polar coordinates. And that's what this 128 expresses here. So what I want you to see here is, how do I express a circle in polar? Because we're dealing really with two circles here. We have one here and one here. And that's really what we're dealing with here. So if we think of, like, let's take this inner circle for first here. We'll take this one. Okay, now again, we're thinking in polar. So if we weren't sure right away what the polar should be, we do know x squared plus y squared equals r squared. We do know that. And we also know x squared plus y squared equaling 9 is going to be this first equation for this circle here. And because that's a circle of radius 3 and we're centered at 0, 0. So hopefully that's okay with you. And if I remember polar transformations, I know that x equals r cos theta. I know that y equals r sine theta. And I also know that x squared, I wrote it up here. I know that one. I'll leave it there. And then I also know that tan of theta equals y over x. Now, knowing all of this, and I'm starting here, tells me that, hey, I have this formula here. So I know that x squared plus y squared is r squared. So I know r squared equals 9. And again, all I'm doing here is turning this rectangular coordinate equation into polar coordinates. So now what I do from here is I square root both sides. Now in general, I have a plus or minus 3, but I'm just going to deal with the 3 for now. So this here would be my equation in polar. Okay, now that's only one part of this. There's another part too that talks about, hey, I don't keep going in a circle. So I have a start and I have an end. So that's where this comes in now. Where does this start and where does this end? So now for this equation, that's where theta comes in. So I ask the question now, what are my parameters of theta? Now, if I understand polar, which hopefully we're okay with, I know if I start this way, oops, went too far, and I reach the edge of the circle that my r is 3, and that's where I'm going to continue. I'm going to create dots on there. But I know that that theta starts at 0. And then if I keep going, and this is how I think of these all the time when I'm dealing with polar. It's like a sweeping. That's how I look at it. I want to put one here because that looks better. Okay, and then I still keep going, and I know this here is pi halves. Honestly, what I'm thinking about here is the unit circle. So then I continue. And then finally I get down to here, and that is called pi radians. Now again, just because I'm using a pi doesn't mean it's radians. Because I'm talking about theta, which theta is an angle, if I don't put any units on it, it's understood to be radians. Now, if I put degrees on that, like I could have pi half degrees. Now that would really just be 3.14 divided by 2. So it'd be about 1.57 degrees. That's what that would equal. So I could do, I could represent degrees in term with pi in it, because pi really is just a number here that works well with circles. That's why a lot of times we get confused and think that that's a unit for radians, and it's not. But anyways, back to Calc 3, enough of trig. Okay, so that's going to run from 0 to pi, and hopefully that's okay with you. So that would be the equation and parameters for that first circle. So again, that would be this circle right here. All right, now for the second one. Now for the other circle here, and that's this one here. We're going to take a look at that is going to be x squared plus y squared equals 5. Or not 5, excuse me, 25, because it's r squared. But if I knew r, this would simplify to r equals 5. So that's what's nice about circles. They're very easy to address in polar. So knowing that's the equation for that, and I would just run through it the same way as I did this one if I was concerned about it. And my theta then would be the same way. So theta is going to run from 0 to pi. Okay, so those are our bounds for our two circles, or I should say semicircles, and the equations for those circles as well. Now for the region, let's put everything together now. So I have my notation. So this is just going to be an r theta. And think about what we're actually doing. This line here means such that, just in case you didn't know or had forgotten. What we're going to do now is we're going to set this up because we don't want just those equations. We want, this whole area here. And we want to talk about it, the parameters of that. So to do that, we're going to say r theta. Now think about this. This inner equation here is r equals 3. The outer one is r equals 5. So we can simply say that r is between 3 and 5. Because every line between it, or every semicircle between those semicircles are also included in this. So it's going to be from 3 to 5. And then I'm say comma 0, theta is between 0 and pi. So that's how I would actually write the domain for this in terms of polar coordinates. Now again, how I set it up in terms of these integrals when we get to it, this information will be used upper lower bound scenario and lower theta and upper theta. So this becomes pretty easy when it comes to circles for sure. But that would be our answer for this one.